Well, hey, welcome back to our series in algebra. I guess that's actually where we are. We are studying algebra this week. Remember, this is just a quick little 1 week mini lesson unit on algebra, something to kind of prep us up. But the cool thing is everything that happens in here is the math that we can and apply with things we already know, right? When we're talking about algebra, we are still understanding that we're just using those four operations we see in math: addition, subtraction, multiplication, and division. It's just recognizing where they are. In the last video, we did talk about those order of operations, right? That PEMDAS. And today we are going to focus on the E of PEMDAS, the exponents. This is something that we haven't seen yet in terms of PEMDAS, but it is something we have worked on briefly. Oh, I wrote it here too. Exponents. So today we're going to take a look into exponents. We're going to look into how to solve exponents, and then we're going to look into what do we do when exponents do show up in our order of operations, in our PEMDAS order of operations. So that's the goal here. Please feel free to have paper and pencil and be taking some notes and making sense of this, keeping it in your journal. Remember, if it's in your journal, you can use it in a test, so it wouldn't hurt to put it in your journal, says Mr. Smiley Face here. All right, so let's dive in. Exponents. So if you remember, our first run in with exponents dealt with what we consider that base 10 multiplication of exponents. And that was basically the idea that, again, our base number was 10 when we did this work. So if I had like 10 to the power of 4, well, that's stating that I have my base number, and I'm seeing my base number as many times as the exponent tells me. Now, again, exponents is a form of multiplication, so that's the operation we'll be using, but it is not a direct multiplication. A lot of mistakes people will make with an exponent, like 10 to the power of 4. They'll be like, oh, 10 times 4, well, that equals 40. No, that is incorrect. And that is a very common misconception people have. I mean, why have exponents if it's just a normal multiplication problem, right? It's multiplication, but it's extreme. Remember, what it means is we have our base number times itself as many times as the exponent says. So I'm actually multiplying all 4 of these 10s together, and you can do it step by step, right? So 10 times 10, that gets me 100. 100 times 10 times 10. So 100 times 10, that gets me 1,000. And then 1,000 times 10 would get me 10,000. And that's actually what 10 to the power of 4 using that exponent equal is 10,000. And we also knew that shortcut, that we know that 1 times 1 times 1 is 1. And then this exponent tells me how many zeros I have. There's 4. Now that works when you have base 10. With exponents themselves, the base isn't always 10, but that's just a review of what we've done. If you remember then that part of what we reviewed, talking about the parts of an exponent, remember you have a base number and then you have the exponent, right? That's what this means. So this is the base number and this is the exponent. And again, like we said in that last example, that could be the fact that we have base 10 to the power of 3, or base 10 to the power of 5, or base 10 to the power of 1. What we're going to look at today's video is what happens when that base is not 10. What does that mean? And that is something we're going to have to know how to do, and you can do, and you will figure it out, and let's play. So let's take our first example, and let's say a base number of 3. And we're going to have it 3 to the power of 2. Sometimes you'll hear that called squared, and we'll dive deeper into that as the year goes on. But yeah, power to 2, or you could say this is 3 squared. And what this means is, again, the same concept we saw when we had base 10 is I have my base number 3, and I have it as many times as the exponent tells me. Well, in this case, the exponent tells me 2 times, so I have 2 3s. And again, I am then multiplying those. So 3 times 3, that gets me 9. So 3 squared, or 3 to the power of 2, is going to get me 9, because that's 3 times 3, right? So the only number you're ever actually writing down is the base number. how many times you write it down is what the exponent tells you. And that's where it gets a little tricky. It's still multiplication, but it's not just a multiplication problem. It's not 3 times 2 equals 6. It's 3 times 3 is 9. So let's look at another one. Let's say, for example, we have 5 to the power of 4. So again, our base number is 5. So that's the only number I'm using. So I'm going to write 5. I'm going to write it in expanded form because we'll see it that way. Now, the exponent tells me how many 5s I have. I have 4 of them. So here's 1, 2, 3, 4. And then again, in between each one of these, we're multiplying. So 5 to the power of 4 is actually a pretty big number because what that is it's 5 times 5 times 5 times 5. Well, 5 times 5 itself is 25 times 5 times 5. Notice this looks a lot like what we did with our order operations. 25 times 5 is 125 times 5. And 125 times 5, well, I guess I'm going to have to do this math over here. I'm going to do a standard algorithm real quick. That's 25, 10, and 12, 5, and 6. So that's 625. So the end of the day, 5 to the power of 4 is equal to 625. So you can see when we get into powers, numbers get really, 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 really big, right? I mean, imagine that. Imagine if I had 5 to the power of 12. Well, that would be 5. That would be 12 5s. 5 times 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 5. I actually have no idea what that answer is, but that was just our example. Okay. Next, let's do another one. Let's take, what did we do the first time? We did a base of 3. We did a base of 5. Let's do something like a base of 8 to the power of 3. One thing you'll know, I don't think we're going to get too big with our exponents as we do this journey. It'll typically be to the power of 2, power of 3, power of 4, power of 5. I don't think we're going to go much higher than that. So don't worry, maybe. But if so, I'm sure the base number will be a little bit smaller. Regardless, what this says here again is only my base number. It's 8. I have 3 of them. They are multiplying by themselves. So this is even going to be a big value because I know that, whoa, I know that that looks crazy. Whoa, again, did it. So, wow, I don't know. Let's try this again. I know that 8 times 8 is 64. I don't know why that was so hard for me to do. And then we're still gonna, that's these two 8s. I still have to take 64 and multiply it by 8, which I don't know off the top of my head. So I'm gonna do some math. I'm gonna do partial products. So 32 and 480 and 2 and 11. So 512. So 8 to the power of 3 is equal to 512, which is interesting. Oh, I skipped too many pages. 5 to the power of 4 is 625, whereas 8 to the power of 3 is 512. So actually 5 to the power of 4 is greater than 8 to the power of 3. And you'll actually start to see things like this when you get into middle school, which is really cool. Maybe you'll see some of them today in your work. Who knows? I might be feeling crazy. All right, so that's exponents at its basic steps, right? Thinking about that base number, and then the exponent is how many times you have that number written down and you multiply it by itself. I'm gonna have to do one more because I feel like I haven't quite reiterated this enough. Let's say base 6. Base 6 to the power of 4 does mean I have 6 times 6 times 6 times 6. I love that I just picked this because now I got to do that math. So 6 times 6 is 36 times 6 more. So that's these two. I don't know that. 36 times 6, 36 and 180. So that's 216. So this is 216 times 6 more, right? 1, 2, 3, and now the fourth one. So 216. Notice, yes, I do have to do math. I do have to do whatever style works best for you. I'm going through a combination of partial products and standard algorithm. I will say that learning standard algorithm is a shortcut. You know, I'm not a fan of it, but it is a shortcut. Does help speed this process up, but you can see here, look how big that is. 6 to the power of 4 is 1,296. Okay, so now let's apply this to PEMDAS, because like I said, we're going to actually see that. So remember PEMDAS, we have the order of operations, or please excuse my dear Aunt Sally, but you know, it means more than that. So we have parentheses, we have exponents. So now we know really what those mean. Remember, we have multiplication or division next. It's whatever you see first moving left to right. So multiplication doesn't always come first. So many people make that mistake. So please remember that. We have addition and subtraction. Again, whatever comes first moving left to right. It's not that addition is always before subtraction. So that's the tricky thing about PEMDAS, is that it's not always just PEMDAS. It could be PEDMOS or PEDMSA. Wow, sorry, I should have written that as I was saying that. But the reality is that multiplication and division are interchangeable. Will they always be before addition and subtraction? Yes. Right? So multiplication and division always does come before addition and subtraction. Anyway, blah, blah, blah. So here's the problem. Let's say we have something like 3 times 5 plus parentheses 5 minus 2 plus 6 to the power of 2. Okay, so let's just break this down and do our PEMDAS, right? Step 1, like you just follow the order of operations. So step 1, we're going to look for parentheses. If we have them, we're going to solve them. Well, here's my parentheses. So the first thing I'm going to do is 5 minus 2. So that's going to get me 3. And then I'm just going to write in the rest of the stuff. Remember, I'm not going to do it all at once, right? Do it step by step. All right, next, go back through the checklist again. We're going to look for parentheses. There are none. So now we're going to look for exponents. There are exponents. So this is 6 to the power of 2, which is that same thing as 6 times 6. So 6 to the power of 2 is going to get me 36 plus 3 plus 5 times 3. Okay, next, we're going to go back through our order operations, and we're going to look for parentheses. There are none. Exponents. There are none. Multiplication or division, whatever I see first moving left to right. And if I move left to right, here it is. I have 3 times 5. So that's 15 plus 3 plus 36. And now I can just finish that out. This is all addition. So here's 18 plus 36. And then to get my final answer, I need to find the sum of 36 plus 18. So 14, 3, 4, 5. So that gets me 54. So there you have it. This is why knowing exponents is so important, because they're going to show up in our order of operations. So with that being said, go ahead and get on the independent work on this, and then your quick check and all those other things that go with this. Feel free to go back and watch parts of this video if you find yourself confused, and also feel free to just ask questions while doing the work. Being independent doesn't mean you cannot ask for help. So I appreciate all that you do, and we will see you next time.